Hello students, today we're going to discuss JEE main questions of a basic chapter, motion in straight line. Also you call it as kinematics. These are the number of questions they asked in January paper, which you call it as attempt 1. And we're going to see all the questions in detail. So to watch more video like this, don't forget to subscribe our channel. We'll see the first question. Position of an ant moving in YZ plane is given by the equation. So they have given the equation of position and they're asking magnitude and direction of velocity at time t is equal to 1 second. So let us take the equation of position. S is equal to 2t square j vector plus 5k vector. If we are differentiating position with respect to time, we will get velocity. So v is equal to ds by dt. Okay. So v is equal to 2 into, if you are differentiating t square with respect to t, it will be 2t into j vector plus 5 is a constant. If you are differentiating constant, it will go to 0. So it's 0. So v is equal to 2 2s are 4 and t is 1 second. So 1 into j vector. So you'll get the answer as v is equal to 4 meter per second and j vector represent ant is moving in a positive y axis, that is positive y direction. So we'll check the option. Option 4 is the right answer. Next question. A bullet is fired into a fixed target, loses 1/3 of its velocity after traveling 4 cm. So with respect to the condition, we'll draw the diagram. Let us consider this is fixed target and the bullet is fired into a fixed target, and let us consider its initial velocity is u. After penetrating, it loses 1/3 of its velocity. So let us consider the initial velocity is u and it loses 1/3 of the velocity. So the balance will be 2/3u. So after covering 4 centimeter, the velocity has become 2/3u. Okay. So the question is, it penetrates further d into 10 power minus 3 meter before coming to the rest. The value of d is. So it penetrates further and it covers a distance d and finally it came to rest. So rest means the final velocity goes to 0. We have to find this distance. So we can take third equation of motion because we don't have time. So the third equation of motion is v square minus u square is equal to 2as. So I'm going to take this as first condition. So this is initial velocity and final velocity. So final velocity is 2/3u. So we can substitute here. So 2/3u the whole square minus u square is equal to 2a. In the place of distance, we can substitute 4 centimeter. So 4 centimeter. Square is 4. So 4/9 u square minus u square is equal to 2a into 4 centimeter. So if you cross multiply means we will get it as 5u square by 9 is equal to 2a into 4 centimeter. So this is equation number 1. Okay. And we'll take the second equation. So this is second equation. This is initial velocity which is 2/3u and final velocity goes to 0 and the distance is d we have to find. So the final velocity is 0 minus initial velocity is again 2/3u the whole square is equal to 2a. In the place of distance we can substitute d. So this is equation number 2. So we'll take the second equation. So if you're taking square means 2 square will be 4. So 4u square, in the place of 3 square we can substitute 9 is equal to 2a into d. This is equation number 2. And we'll substitute the first equation. 5u square by 9 is equal to 2a into 4 centimeter. This is equation number 1. So I'm going to divide this both. So if you're taking a ratio means 2a will get cancelled. 9 u square will get cancelled. So if you cross multiply means 4 4s are 16. So 16 centimeter by 5 is equal to d. So 16 by 5 is 3.2 centimeter. But they are asking in meter. So we can write it as 10 power minus 2 meter, that is equal to d. But they asked in the form of 10 power minus 3. So we can write it as 32 into 10 power minus 3 meter. In place of d you have 32. 32 is the right answer, but in the option you don't have 32. So it's a bonus question. If you attend this question, you'll get the bonus points. So it's a bonus question. Next one, a body falls under gravity, cover 2 points A and B, separated by 80 meter in 2 seconds. So we'll draw the diagram. Let us consider a body undergoes a free fall, which means the initial velocity goes to 0. So it will come down due to the gravitational force, so the velocity will increase. So it covers 2 points, so which is A and B. Let us consider this point is A and this is B. So between A and B, you have the distance of 80 meter, which covers in 2 seconds. So they're asking the distance of upper point A from the starting point. So they're asking this distance, the height h. Okay. So first we have to find the velocity at point A. Then we can proceed the problem. So the distance between A and B is 80 meter and the time is 2 seconds. So here you have to find the velocity. So let us consider that velocity is V. So we can take second equation of motion, which is S is equal to ut plus half at square. In the place of A, we can substitute G because it comes down due to the gravitational force. So its acceleration due to gravity. So this distance is 80. So 80 is equal to, in the place of U, we can substitute V. So V and time is 2 plus half in the place of A, which is G, and time T is again 2 square. So 2 will get cancelled. So 80 is equal to 2V plus in the place of G we can substitute 10. So 10 into 2 means which is 20. If you're taking 20 to the opposite side, it will become 60 is equal to 2V and V is 30 meter per second. Okay. So we found the velocity which is 30 meter per second. So from this data, we can find the upper distance. So this velocity is 30 and here the initial velocity goes to 0 and we have to find this distance. So we can take third equation of motion, which is V square minus U square is equal to 2AS. So final velocity is 30 square and initial velocity 0 is equal to 2. In the place of A, which is G, we can substitute 10 and we have to find the distance H. So 30 square is 900. 900 is equal to 20h. So now 0 will get cancelled. So h is equal to 90 by 2. So 90 by 2 is 45 meter. So 45 is the right answer. So 45. Now we'll see the second day question, that is 29 January. A body starts moving from rest with constant acceleration covers displacement s1 in first p minus 1 second and s2 in first p second. Now we'll take the given data. It starts from rest, so initial velocity goes to 0 and time t is equal to p minus 1 second. It covers a displacement s1 and time t is equal to p second. It covers a displacement s2. So now we'll take the equation. We'll take second equation of motion because they have given time and displacement relation. So we can take S is equal to ut plus half at square. So it starts from rest, so initial velocity goes to 0. So this term will go to 0. We'll substitute the condition in the displacement S1. The time is p minus 1. So S1 is equal to 1 by 2a. In the place of t, we can substitute p minus 1 the whole square. So we can expand the equation because it's a minus b the whole square. So S1 is equal to 1 by 2a into p square plus 1 minus 2p. Okay, so let it be the equation number 1. And now we will substitute the condition for the second equation, which is displacement S2 is equal to 1 by 2a and the time is p square. This is equation number 2. The question is the displacement S1 plus S2 will be made in time. So we have to add this both the equations. So if we add means S1 plus S2, that is equal to, if adding this both means 1 by 2 and A is common and balance is P square plus 1 minus 2P and plus P square. And here it will be p square plus p square will be 2p square. So S1 plus S2 is equal to 1 by 2a into 2p square plus 1 minus 2p. And they're asking time, so we'll compare with the original equation. So S1 plus S2, that is equal to 1 by 2a and this is time, so we can substitute t square. They're asking time only. So we can compare this both. In the place of t square, you have this one. So we'll take it out, which is t square is equal to 2p square minus 2p and plus 1. And you're going to take square to the opposite side. So t is equal to square root of 2p square minus 2p plus 1 seconds. So we'll check the option. Option 2 is the right answer. Next one, a particle is moving in a straight line. The variation of position x as a function of time is given by the equation. They have given the equation for position. The velocity of a body when the acceleration becomes 0. So first we'll take the equation for position, which is x is equal to t cube minus 6t square plus 20t plus 15. So if we're differentiating position with respect to time, we will get velocity. So velocity is dx by dt. So we're going to differentiate. So t cube will be 3t square minus 6 into t square will be 2t and plus 20, t will become 1 and 15 is constant, so that will go to 0. So velocity v is equal to 3t square minus 6 into 2 is 12, so 12t plus 20. So this is the equation of velocity, but they are asking the velocity where acceleration goes to 0. So we have to take the equation for acceleration. So again, if you are differentiating velocity with respect to time, we will get acceleration. So that is equal to 6t minus 12, t will become 1 and 20 is constant, that goes to 0. Okay. So this is the equation for acceleration. A is equal to 60 minus 12. So acceleration becomes 0. So this is equal to 0. So 6t is equal to 12. So t is equal to 2 seconds. So at time t is equal to 2 seconds, acceleration goes to 0. At this time, we have to find the velocity. So I am going to substitute this time in this equation. So v is equal to 3. In the place of t square, we will substitute 2 square minus 12 into, in the place of t, again we can substitute 2 plus 20. So 2 square is 4, 4 3s are 12. So 12 minus 24 plus 20. So 12 minus 4, which is equal to 8 meter per second. So we'll check the option. Option 2 is the right answer. Question is, the displacement and increase in velocity of a moving particle in the time interval of t to t plus 1 second are 125 meter and 50 meter per second respectively. Let us consider a particle undergoes uniform acceleration at time interval of t is equal to t to t plus 1 second. It covers a distance of 125 meter and the increase in velocity, that is a change in velocity, is 50 meter per second. And the question is, the distance traveled by the particle in time t plus 2 seconds is. So we have to find the distance in the nth second. So we can take the formula as n is equal to u plus a n minus 1 by 2. So to handle this formula, we have to find the initial velocity u and acceleration a. Okay. So let us consider it undergoes a uniform acceleration. With respect to that, we can find the initial velocity and acceleration. To find that, first formula we're going to use is v is equal to u plus at. So at time interval t to t plus 1 second, the change in time is 1 second. Okay, we have to find the final velocity. So final velocity is, initially we have some initial velocity u. To this part we have some initial velocity u and increase in velocity is 50. So we can write the final velocity as u plus 50 is equal to initial velocity u we have to find plus a, acceleration is uniform acceleration a and time interval is 1 second. Okay, so u will get cancelled. So a is equal to 50 meter per second square. So we found the acceleration a. So with respect to that, we can find the initial velocity u. So for that, I'm going to take the second equation of motion, which is s is equal to ut plus half at square. So the distance covered in this time interval 1 second is 125 meter. So 125 meter, that is equal to initial velocity u. Again time interval is 1 plus half, a is 50. Again time interval is 1 square. So we can cancel. It's 1 and 25. You're taking 25 to the opposite side means 125 minus 25, which will be 100. So 100 meter per second is the initial velocity u. So we found initial velocity u and acceleration a. So we can substitute in this equation. So here they ask the time interval of t to t plus 2. That means the time interval will be, that is a change in time will be 2 seconds. So in the place of n, we can substitute 2. So Sn is equal to u is 100 plus a is 50 and change in time is 2. 2 minus 1 by 2. So 100 plus 50. So if we cross multiply means 4 minus 1 will be 3. So 3 by 2, which is 1 and 25. So 25 into 3 will be 75. So 100 plus 75 is 175 meter. So the answer is the distance traveled in t plus 2 seconds is 175 meter. Next, the relation between time and distance x is equal to t is equal to alpha x square plus beta x, where alpha and beta are constant. The relation between acceleration and velocity. First, we'll take the equation. So, t is equal to alpha x square plus beta x. We can do partial differentiation. So, in this side, I'm going to differentiate with respect to t. So, if you're differentiating t means that will become 1 into dt, that is equal to, and this side alpha into 2x plus beta x will become 1 into dx. Okay, so if we cross multiply means 1 by 2 alpha x plus beta is equal to dx by dt, which will become velocity. So velocity is equal to 1 by 2 alpha x plus beta. We found out velocity, so this is equation number 1. And now we will try to find the acceleration. So again we can take the same equation, which is 1 is equal to 2 alpha x plus beta, and dx by dt, that will become velocity v. Okay, we'll take v inside. So 1 is equal to 2 alpha x v plus beta into v. So again we will differentiate. So if you're differentiating 1 means that will go to 0, that is equal to 2 alpha. So both x and v will differentiate with respect to time. So we'll take uv method. So this is u and this is v. So we'll keep x as constant and we will differentiate dv by dt, and then we will keep v as constant. We'll differentiate x with respect to time. Okay, so it's uv method plus beta into dv by dt. Okay, so we will substitute. So 0 is equal to 2 alpha x into dv by dt is acceleration a plus v, again dx by dt is again a velocity, we can substitute as v square plus beta into, and this is again acceleration a. Okay, so now we'll reform the equation. So 0 is equal to 2 alpha x into a plus 2 alpha v square plus beta into a. So we'll take this term to the opposite side. So it will be minus 2 alpha v square is equal to, we can take a as common. So a into 2 alpha x plus beta. Okay, we can take this term to the opposite side. So it will be minus 2 alpha v square by 2 alpha x plus beta is equal to a. So we know this term as velocity. So we can substitute as a is equal to minus 2 alpha v square, and this term is again a velocity. So we can write it as b. So it will be a is equal to minus 2 alpha v cube. So we'll check the option minus 2 alpha v cube. Option A is the right answer. Next one, it's a repeat question. The same pattern of the question they asked in 29th January shift 2. So the same pattern they asked it here also. So it's a repeat pattern. Now we will see the question. A particle moving in one dimension under the action of variable force. Its initial position was 16 meter right of the origin. The variation of the position. So they have given the equation for the position and they are asking velocity of the particle when acceleration becomes 0. So we're going to handle in the same way. So if you're differentiating position with respect to time, we will get velocity. So now we will differentiate. So v is equal to minus 3t cube, that will become minus 3 into 3t square plus 18 into t square will become 2t and plus 16 t will become 1. So velocity is minus 9t square plus 36t plus 16. So if you're differentiating velocity with respect to time, we will get acceleration. So a is equal to dv by dt. The acceleration a is equal to minus 18t plus 36. So 16 is a constant, that will go to 0. So they have told acceleration is 0. So we can equate this is equal to 0. So 36 is equal to 18t, be 1 and 2, and time t is equal to 2 seconds. So they asked velocity. So at time t is equal to 2 seconds, acceleration goes to 0. We have to find the velocity. So I'm going to substitute t at this equation. So v is equal to minus 9. In the place of t, we can substitute 2. So 2 square plus 36 into 2 plus 16. So 2 square is 4. So 4 into 9 is 36. So minus 36 and plus 36 into 2 plus 16. So this will become, so minus 36 plus 36 into 2, that will become 36 plus 16. So the answer will be 52 meter per second. So the velocity is 52 meter per second. Next one, direction type question. A train A is moving along two parallel rail tracks towards north with speed 72 km per hour, and train B is moving towards south with speed 108 km per hour. So first we have to convert kilometer per hour to meter per second. So velocity of train A is 72 km per hour. To convert to meter per second, you have to multiply 5 by 18. So if you cancel, this is 1 and 4. 4 5s are 20, which is 20 meter per second. And same way, velocity of B, that is equal to 108 into 5 by 18. So if you cancel, again 1 and 6, 6 5s are 30. So which is 30 meter per second. Okay. So the question is velocity of B with respect to A. So we have to see the velocity with respect to A. So the train A is moving towards north. We can take that as positive. So north direction, velocity of A, which is plus 20 meter per second. So we'll see train B. So it's moving south, which is in opposite direction. So opposite direction means we have to substitute as minus. So velocity of B is minus 30 meter per second. Okay. So they asked velocity of B with respect to A, which is VB minus VA. So VB is minus 30, minus VA is 20. So which is minus 50 meter per second. Okay. So this is relative velocity. And next they ask the velocity of ground with respect to B. So with respect to B, we have to see the velocity of ground. That will be the original velocity of train B, which is 30. So the answer is, first one they ask relative velocity that we found out, which is minus 50 meter per second. And second one is they ask the velocity of ground with respect to B. That is the original velocity of B, which is 30 meter per second. So minus 50 meter per second and 30 meter per second. So option 3 is the right answer. Last question, a particle initially at rest starts moving from reference point x is equal to 0 along x-axis with velocity v varies. So they have given the equation for velocity. They are asking acceleration. So first we'll take the equation. V is equal to 4 x power, in the place of root I'm going to substitute as 1 by 2. And now we have to find the acceleration. So we can do the partial differentiation. So first dv is equal to 4 into 1 by 2 x power minus 1 by 2 into dx. Okay, so what I'm going to do is I'm going to multiply and divide by dt. So we'll multiply and divide by dt, and I can take this dt to the opposite side. So this will become dv by dt is equal to, so if we cancel, this is 1 and 2, 2x power minus 1 by 2 into dx by dt. So dx by dt is again a velocity v. So we can substitute that one. So 2 into x power minus 1 by 2. In the place of dx by dt is a velocity v. So we know what is velocity. So we'll substitute that one. So 4 into x power 1 by 2. So this both will cancel. So balance 2 4s are 8. So 8 meter per second square. This is acceleration A. So the answer is 8. That's it, we came to end of the session. So if you have any doubts or queries, or if you have any suggestion regarding the videos, please drop it in the comment box. And to watch more videos like this, don't forget to subscribe and like the video. Thank you, students.